You were taught that space is dark because it is empty. Almost everyone was. It is the most reasonable sounding fact in astronomy, and it is wrong. Here is what gets left out of it. If the universe is large and old and has stars scattered through it, then every direction you could possibly look must eventually end on the surface of a star, and the entire sky should be a seamless sheet of light, as bright as the surface of the sun, with no night in it anywhere and no ocean left on this planet. Johannes Kepler worked that out in 1610. The gap between that prediction and the sky above your house is a factor of about 10 trillion, one of the largest disagreements between theory and observation anywhere in physics. It took our species 350 years to work out why. By the end of tonight, you will know exactly why the sky is dark and what that darkness has been measuring the whole time. Get cozy. If you're the kind of person who likes finding out that something completely ordinary has been evidence all along, a quick like and subscribe helps this channel reach more curious minds like you. Because by the end of this, the black between the stars will never look empty to you again. Let's slowly settle into the dark. The darkness above your head is the largest unexplained thing you've ever seen, and almost nobody has ever told you that it needs explaining at all. Think about what you actually do when you look up at a clear night sky. You find the bright things. Your attention goes straight to the stars, to the planets if any are up, to the moon if it is out, to the pale band of the galaxy if you're somewhere dark enough to see it. You look at the light. Everyone does. The light is the part that seems to require an explanation, and over the last few centuries we have built an extraordinarily detailed one. We can tell you what those points of light are made of, how hot their surfaces are, how far away they sit, how they were assembled, how long they have left, and what they will leave behind when they are finished. We have read the light very thoroughly. What we almost never do is look at the other part. The sky is not mostly stars. The sky is mostly the space between the stars, and the space between the stars is black. Overwhelmingly, almost perfectly black. If you took a photograph of the night sky and counted the pixels containing a star would be a rounding error and everything else would be dark. The dominant feature of the night sky, by an enormous margin, is not the light. It is the absence of light. And you have looked at that absence every clear night of your life without once being asked to account for it, because it seems like the most obvious thing in the world. Space is empty, and empty things are dark, and that is the end of the matter. That intuition is wrong, and it is not slightly wrong. It is one of the largest and most durable errors in the way ordinary people picture the universe, and the correct answer took the human race 350 years to work out. During those 3.5 centuries, some of the most capable thinkers who have ever lived stared at this problem, understood exactly how serious it was, and could not solve it. They proposed answers that turned out to be wrong. They proposed answers that were nearly right and were ignored. One of the best attempts of the 19th century came from a man who wrote horror stories for a living, and it was dismissed for almost 100 years. The final resolution required accepting something about the universe that nobody in the 17th, 18th or 19th centuries was willing to accept, and it did not arrive properly until the 1960s. Here is the problem in its simplest form, and I want to walk into it slowly because the argument is easy to follow, and that is exactly what makes it so difficult to escape. Suppose the universe is very large, not necessarily infinite, but large enough that stars keep going as far as you care to look. Suppose it has been around for a very long time, and suppose the stars are scattered through it in a reasonably even way, so that if you fly off in any direction you keep encountering roughly the same density of stars as you find around here. None of those three assumptions is exotic. They are close to what most people would guess if you asked them to describe the universe in one sentence, and they were close to what educated Europeans believed by about 1600. Now pick a direction. Any direction at all. Look at a random patch of black sky, one that appears to contain nothing whatsoever, and follow the line of your gaze outward. It leaves the atmosphere. It passes through the solar system, out past the orbit of Neptune, out through the cloud of comets that surrounds us. It crosses into interstellar space and keeps going, past the nearest stars, out through the disk of the galaxy. It leaves the galaxy, it crosses the gap to the next one and the next, and it keeps going. If the stars really do continue on more or less forever, then that line has to hit something eventually. It cannot travel forever through a universe densely furnished with glowing objects and never encounter one. Sooner or later, that line terminates on the surface of a star, and the same is true for the line just next to it, and the one next to that, and every other line you could possibly draw from your eye out into the universe. Every one of them ends on something burning, which means the sky should be white, not sprinkled with white dots on a dark background. White. A continuous, seamless surface of light in every single direction, with no gaps in it anywhere, glowing at the temperature of a stellar surface, which for a star like the Sun is somewhere around 5,770 Kelvin. The entire dome of the sky, horizon to horizon, at the temperature of the surface of the Sun. It would not go dark when the Sun set, because the sun setting only removes one source out of an unbroken sheet of them. Night would not exist. The ground would be at that temperature too. So would you. The oceans would have boiled off long before anything was around to look up. And yet you can walk outside tonight, and the sky will be black, and the temperature will drop, and nothing whatsoever will be on fire. So one of the assumptions has to be wrong, and it is not immediately obvious which one. The universe might not be as large as it appears. It might not be as old as it appears. The stars might not be spread out evenly. Something might be in the way. Something might be draining the light. Or the argument itself might contain a mistake somewhere, some subtle error in the geometry that dissolves the whole thing. Every one of those escape routes has been tried. Most of them were tried by people whose names you would recognize. Most of them fail, and the ways in which they fail are more interesting than the proposals themselves, because each failure narrows the space of possible answers until only one region is left standing, and the thing waiting in that region is not comfortable. This problem has a name. It is usually called Olbers's paradox, after a German physician and astronomer named Heinrich Wilhelm Olbers, who wrote about it in 1823, which is a slightly unfair piece of naming, because Olbers was not the first person to notice it, or the second, or the third, and the answer he proposed was wrong. Johannes Kepler was worrying about it in 1610. Edmund Halley, of the comet, discussed it in 1721. A Swiss astronomer named Jean-Philippe de Chezeaux worked through the mathematics properly in 1744. The paradox is one of the oldest live questions in astronomy, older than the telescope's 2nd century, older than the discovery of Uranus, older than the idea that stars are other suns is old in the popular imagination. And I want to be clear about the shape of what we are doing tonight, because the resolution of this paradox is not a single fact that you can be handed and then put away. It arrives in layers. The first layer is a genuine answer, and it is satisfying, and it is correct as far as it goes, and most explanations you will find stop there. The second layer sits underneath the first one and is considerably stranger, and it says that the first answer, while true, is not actually doing most of the work. And underneath that there is a third layer, which reverses the entire question and says that the premise we started from, the premise that the sky is dark, is itself false, and that the sky above you at this moment is in fact blazing with light in every direction, exactly as Kepler feared, and that you cannot see it for a reason that has nothing to do with astronomy and everything to do with the equipment you're using to look. By the end of tonight you will have all 3 layers, in order, and you will know precisely why the sky is dark and what that darkness is a measurement of, and what it is quietly telling you about how much time the universe has left as a legible object. For now, hold on to just one thing, because everything else is going to be built on top of it. The darkness overhead is not the natural expected default state of things. It is not what you get for free when you take the stars away. It is a specific physical condition that requires a specific physical explanation, and the explanation turns out to be about time, and about fuel, and about the narrowness of human eyes. The first person to state this problem clearly did so more than 400 years ago, and he drew a conclusion from it that sounds absurd today, and was, in a way that almost nobody appreciates, very nearly correct. In 1610, a book arrived in Prague that changed what the night sky was, and the man who read it understood within days that the darkness had become a problem. The book was Galileo's report of what he had seen through his new telescope. It is a thin document, and it is one of the most consequential things ever published. Galileo described mountains on the moon, 4 objects circling Jupiter, and, the detail that matters for us, stars, enormous numbers of stars. When he turned the instrument on the Milky Way, that soft band of light resolved into individual points, thousands of them, in places where the unaided eye saw only a faint smear. Every patch of sky he examined contained more stars than anyone had known were there. The catalogues of antiquity listed about 1,000. Galileo was finding that many in small regions. Johannes Kepler received a copy in April of 1610 and responded almost immediately with a short public letter, and inside that letter is the first clear statement of the problem we are dealing with tonight. Kepler was not disputing the observations, he was worried about what they implied. The intellectual context matters here. For several decades, a genuinely radical idea had been circulating in Europe, that the universe might be infinite, and that the stars might not be lamps fixed to a sphere but other suns, spread through unlimited space, each one potentially with worlds of its own. An English astronomer named Thomas Digges had published a diagram in 1576 showing stars scattered outward without any boundary. Giordano Bruno had argued for an infinite universe of countless suns, among other things, and had been burned at the stake in Rome 10 years before Galileo's telescope. The idea was in the air, and it was dangerous, and it was gaining ground. Kepler did not like it, and Galileo's countless new stars sharpened his objection into something quantitative. His reasoning ran roughly like this. If the stars are suns, and if they go on without limit through infinite space, then the sky should be uniformly bright. Every direction would be filled. There would be no gaps because there would be no direction in which you could look without eventually finding a star. The sky, he said, ought to blaze like a single continuous surface of fire, and it does not. So, Kepler concluded, the universe is not infinite. There must be a boundary. He pictured a dark wall enclosing the region of the stars, a finite cosmos with an edge to it, beyond which there was nothing, and the blackness we see at night is that wall showing through the gaps. It is easy to be condescending about this, and I want to resist that, because the reasoning is genuinely excellent. Kepler looked at the sky, extracted a quantitative prediction from a cosmological model, compared the prediction to observation, found a violent disagreement, and rejected the model. That is not medieval thinking. That is exactly the procedure we still use, and more than that, his central conclusion, that the darkness proves the universe cannot be unlimited in the way the infinitists were claiming, is correct. The darkness really does prove that something about the universe is bounded. He simply guessed the wrong dimension. The limit is not a wall out there in space, it is a limit in time, and nobody in 1610 had the conceptual equipment to think of time as the sort of thing that could have a boundary. Kepler died in 1630, and the problem sat quietly for most of a century. There is a detail in his reasoning that deserves more attention than it gets. Kepler was not arguing from taste or from doctrine. He was arguing from a photometric estimate, from the observed amount of light in the sky compared to the amount an infinite universe would supply. That is an argument of exactly the kind we still make. He was using the sky as an instrument and reading a value off it, 3 centuries before anyone had a name for that procedure. And the conclusion he drew has an odd afterlife. Kepler said the darkness proves the universe is enclosed, and the modern answer says the darkness proves the universe is limited in time. Those sound like completely different claims, and in one sense they are, but they share a structure. Both say that the blackness is evidence of a boundary, and both are correct that the sky is telling us where the universe stops being available to us. Kepler found the right question, and identified the right kind of answer. He simply had no way to conceive of a boundary that was not made of something. Edmund Halley picked it up again in 1721. Halley is remembered for the comet, but he was one of the most versatile scientists of his period, and by this point he was Astronomer Royal, and in his 60s. He presented 2 short papers to the Royal Society in London addressing exactly this question, whether an infinite universe of stars would produce a bright sky, and he came away with an answer that is not quite right but is interesting anyway. Halley suggested that the more distant stars would simply be too faint to register. Their light spread out over such enormous distances would fall below any threshold of visibility, and so the far reaches of an infinite universe would contribute effectively nothing. That sounds reasonable, and it is completely wrong, for a reason that becomes obvious once you see it. It is true that each individual distant star becomes fainter, but there are more of them out there, and the number grows exactly as fast as the individual brightness falls. Halley was thinking about single stars when he needed to be thinking about the total from all of them at once. The correction is not a technicality. It inverts the conclusion entirely. The person who did the arithmetic properly was a young Swiss astronomer named Jean-Philippe Loy de Chézeux. who published his treatment in 1744 as an appendix to a book about a spectacular comet he had observed. De Chezaux is not a famous name, and he should be. He set the problem up cleanly, he did the geometry that Halley had fumbled, and he arrived at a number. He calculated that if stars fill infinite space at the density we observe locally, the whole sky should glow at something like the brightness of the sun's own surface, and he estimated that a line of sight would have to travel an extraordinary distance before terminating on a star, a figure so large that it took him beyond any distance anyone had a name for at the time. So by the middle of the 1700s the problem was fully formed, quantitatively stated, and published. And de Chezaux then proposed a solution, which was that some thinly spread absorbing medium fills the space between the stars and soaks up the light from the most distant ones before it reaches us. It is the obvious answer. It is the answer almost everyone reaches for the first time they hear the problem. It happens to be impossible, and we will spend real time later on exactly why, because the reason it fails is one of the most elegant pieces of physics in this whole story. Heinrich Wilhelm Olbers arrives in 1823, and he is a slightly odd figure to have the paradox named after him. He was a physician in Bremen who practiced medicine during the day and did astronomy from the top floor of his house at night, and he was very good at it. He discovered 2 asteroids and a number of comets, and there is a method for computing cometary orbits that still carries his name. In 1823 he published a piece restating the darkness problem and proposing, as his solution, an absorbing medium in space. In other words, he restated de Chezaux's problem and repeated de Chezaux's wrong answer, 80 years later. Why does it bear his name then? Largely because of a paper written in the 1950s by the cosmologist Hermann Bondi, who was working on rival theories of the universe at the time and needed a compact label for the darkness problem. He called it Olbers' paradox. The phrase stuck, and now a Bremen doctor is permanently attached to a puzzle he neither invented nor solved. The history of science is full of this. Names are not assigned by merit. They are assigned by whoever wrote the sentence that got repeated. What I want you to take from these 400 years is not the sequence of names, it is the shape of the thing. Every one of these people was looking at the same sky you can walk outside and look at tonight. None of them lacked the observation. The observation is free, and it is available to anyone with eyes, and it has been available to every human being who has ever lived. What they lacked was a way of reading it. The information was sitting there, unencrypted, above every city and every field and every ocean on this planet. For the entire history of our species, and for most of that history we did not know it was information at all. And the reason nobody could read it is worth stating plainly, because it explains the 350-year delay. To solve this problem, you have to be willing to say that the universe has not always existed. Every one of these people, Kepler, Halley, de Chezaux, Olbers, was working inside a picture in which the cosmos was eternal, or at least in which its beginning was a matter for theology rather than for measurement. The idea that the age of the universe is a physical quantity, a number you could in principle determine from data, was not on the table. It did not become available until the 20th century, which means the escape route we are about to explore was the only kind of escape route anyone could look for at the time. If you cannot question the age of the universe, and you cannot question its size, and you can see with your own eyes that the sky is dark, then the only remaining option is to put something in the way. So let us do what de Chezaux did, properly and slowly, and build the paradox the way he built it. Because until you have felt how tightly the geometry closes, you will not understand why intelligent people spent 200 years reaching for anything that might loosen it. The paradox is built out of 2 facts that pull in opposite directions and cancel each other so precisely that the result is almost impossible to argue with. Here is the first one, and you already know it, even if you have never written it down. Light spreads out. A source of light throws its energy in all directions, and as that energy travels it is distributed over the surface of an expanding sphere. Double the distance and the same amount of light is spread over 4 times the area, so the brightness you receive drops to a quarter. Triple the distance and it drops to a 1/9. This is the inverse square law, and it is why a candle across a room is dim and a candle at arm's length is bright, and it is why the enormously luminous stars of the night sky are pinpricks. It is the reason distance kills light, and it is the intuition almost everyone reaches for when they try to explain why the sky is dark. Things far away are faint, obviously. That is why space is black. Now the second fact, which is where the argument turns. Imagine wrapping a thin shell around yourself, a spherical shell of some fixed thickness, say 1 light-year thick, at a distance of 100 light-years. That shell has a certain volume, and if stars are spread evenly through space, it contains a certain number of stars. Now imagine a second shell of the same thickness, but at 200 light-years. Its volume is larger because the surface area of a sphere grows with the square of its radius. Twice the distance means 4 times the area, and since the shell is the same thickness, 4 times the volume, and therefore 4 times as many stars inside it. Look at those two numbers side by side. At twice the distance, each individual star is 1/4 as bright, and there are 4 times as many of them. The two effects cancel exactly, not approximately, exactly. The total amount of light arriving from the shell at 200 light-years is identical to the total arriving from the shell at 100, and the shell at 10,000 light-years contributes the same again, and the shell at 10 million. Every shell, out to any distance, delivers precisely the same quantity of light to your eye, because in a universe with stars spread evenly, the diluting effect of distance and the accumulating effect of volume are the same effect running in opposite directions. Sit with that for a second, because it is the hinge of everything. Distance does not reduce the light arriving from a region of space. It reduces the light arriving from each object in that region, and it increases the number of objects, and these two changes have the same magnitude and opposite signs. In a uniform universe, remoteness is not a defense against light. There is no falling off. There is no diminishing contribution from the far reaches. The most distant shell you can imagine is pouring exactly as much light into your eye as the nearest one. So now add them up, shell after shell, each contributing an equal amount, out to whatever distance the universe extends. If the universe goes on forever, you are adding an equal quantity an unlimited number of times, and the sum has no upper bound. The predicted brightness of the sky is not large, it is unlimited. Now, in reality, it does not run to infinity, and the reason is a correction that makes the picture worse rather than better. Stars are not mathematical points, they have surfaces, and a near star will block a far one directly behind it. Once you account for that overlap, the sum stops diverging and settles at a specific value, the surface brightness of a typical star, which is exactly what you would expect, and it is the same conclusion by a different road. If every direction eventually terminates on a stellar surface, then the sky is a mosaic of stellar surfaces with no grout between the tiles, and a mosaic of stellar surfaces is, to your eye, indistinguishable from one enormous stellar surface. The sky becomes the sun, all of it, every direction. There is a version of this argument that I find more physical than the shells, and it may help if the geometry feels abstract. Picture yourself standing in a forest. Not a sparse one, but a forest that goes on for hundreds of miles in every direction, with trees scattered at random. Look horizontally. Close by you can see between the trunks. A bit further out the gaps are narrower, because more trunks are competing for the same angular space. Further still the trunks overlap, and beyond a certain distance every possible sight line runs into wood. You cannot see out of the forest. It does not matter how far the forest extends past that point, 100 miles or 100,000. Because you cannot see past the wall of trunks that has already formed. Your view terminates on bark in every direction. The universe, in the model we are testing, is that forest, and the trees are on fire. There is a piece of physics underneath this that makes the conclusion even harder to dodge, and it is worth having, because it is the thing that turns the shell argument from a counting exercise into something unavoidable. It concerns the difference between how much light you receive from an object and how bright that object's surface appears. Take a wall painted white and lit evenly. Stand a metre away and look at it. Now walk back to 10 metres. The wall does not look darker, it looks smaller, and you are receiving less total light from it, but every square centimetre of it appears exactly as bright as it did before. That is not an illusion. Surface brightness is genuinely independent of distance. The inverse square law reduces the light arriving from each patch of the wall, and it reduces the apparent size of that patch by exactly the same factor, and the two cancel. The same is true of a star. If you could somehow resolve the disk of a distant star, actually see it as a circle rather than a point, that circle would be exactly as bright per unit area as the surface of the sun, no matter how far away it was. It would just be extraordinarily small. Stars look faint to us not because their surfaces are dimmed by distance, but because those surfaces subtend an absurdly tiny angle, and all that light gets averaged over the much larger patch of sky your eye treats as a single unit. So now ask what happens when the stars are packed densely enough that their disks, however tiny, cover the sky completely. You get a surface made entirely of stellar surfaces, and because surface brightness does not fall off with distance, that composite surface is exactly as bright as the surface of one star seen from a few meters away. This is why the answer is so specific and so severe. The paradox does not predict a sky that is somewhat brighter than we observe. It predicts a sky at a particular calculable brightness, the brightness of a stellar photosphere, with no dependence on how the stars are arranged or how far away they are. Rearrange them however you like, spread them thinner and require a larger volume, bunch them up and require less. The answer does not move. As long as the lines of sight all terminate on burning surfaces, the sky is the surface of a star, and that is that. Let me put you inside it properly, because this is the moment where the argument stops being arithmetic and starts being a place. You're standing outside on a clear night, and the sky is behaving normally, and I'm going to start adding the universe in layers. The first shell is close. A handful of stars, bright and separated, plenty of black between them. That is the sky you know. Now the second shell arrives, further out. 4 times as many stars, each a quarter as bright, dimmer individually, but there are more of them, and some of the black between the first stars begins to fill in with faint points. Now the third shell. 9 times as many stars, and they are fainter still, and the gaps narrow again. Watch what is happening to the black. It is not staying black. Every layer I add is putting light into the spaces the previous layer left open, and every layer is putting in exactly as much light as the one before it, and I have not stopped adding layers. 10,000 shells out, there is no black left that you would recognize as black. There is a faint continuous glow with the nearby stars sitting on top of it, like lamps against a lit ceiling. 1,000,000 shells out, the glow is no longer faint. It has the brightness of an overcast afternoon, and the individual stars are becoming difficult to pick out, the way you cannot pick out a torch beam against daylight. And I keep going, because the universe keeps going, and the sky keeps getting brighter, and at some point every direction you can turn your head toward is the surface of a star, and the light is coming from everywhere at once with no shadows anywhere, because there is no direction that is not a source, and it is not the colour of the night sky or the colour of daylight, but the colour of the surface of the sun, and it does not stop when the earth turns, because there is no longer any such thing as turning away. That is the prediction. That is what the model says the sky above you is, and the model is not made of exotic assumptions. It requires only that the universe be big, be old, and have stars in it in roughly the way it appears to have stars in it. Every step of the arithmetic is something you could do on paper in an afternoon. I want to give you the sentence that the whole video hangs from, and I want you to hold on to it, because it is going to come back much later in a form you will not expect. The paradox stripped down is a single claim. Every line you look along must end on the surface of a star. That is the prediction. Every line. Not most of them, not the lucky ones. Every possible direction without exception terminates on something burning. If the universe is large and old and evenly furnished, this is not a probabilistic statement. It is a geometric certainty, and the darkness overhead is a direct and violent contradiction of it. There is one more number worth having in hand before we move on, because it tells you how badly the actual universe fails to be the forest we just described. Given the real density of stars, how many there are per unit volume, and how big they are, you can calculate how far a line of sight would have to travel on average before it struck a stellar surface. The answer comes out at something on the order of 10 to the 23 light years. That is a 1 with 23 zeros after it. For comparison, the entire region of the universe we can observe is about 93 billion light-years across, which is a 1 with 11 zeros. So a typical line of sight would need to run something like 1 trillion times further than the whole observable universe before it hit anything. In practice, almost every direction you look does not terminate on a star. It goes out and simply keeps going. Which sounds, on first hearing, like the answer. There you go. The stars are too thinly spread, the universe is not full enough, the forest is not dense enough to close up. Problem solved. It is not solved, and the reason it is not solved is that the shell argument never depended on the forest closing up nearby. It depended on the sum. You do not need the universe to be dense. You need it to be large, and to have been running long enough for all that light to arrive. Thin out the stars and you do not reduce the total. You just require a larger volume to reach the same result. The sum does not care. It is patient. Given enough space and enough time, a very sparse universe produces the same blazing sky as a crowded one. It just takes longer. So the density figure is not an escape. It is a clue, and it is pointing somewhere specific, and we are not ready for it yet. What we are ready for is the size of the failure, because it is one thing to say the prediction is wrong. It is another thing entirely to measure how wrong, and when you actually put a number on the gap between the sky we predicted and the sky that is up there, you get one of the largest disagreements between theory and observation anywhere in physics, and it is sitting above your house. Physics is full of predictions that come out slightly wrong, and the interesting ones are usually wrong in the third decimal place. This one is wrong by a factor of about 10 trillion. Let me build that number carefully, because a figure that large stops meaning anything if you just say it. Astronomers measure how bright a patch of sky is using a scale called surface brightness, expressed in magnitudes per square arc second. A square arc second is a tiny piece of sky, roughly the area the head of a pin would cover if you held it about 200 meters away. The magnitude scale runs backwards, which is a piece of inherited awkwardness from the ancient Greeks. Bigger numbers mean fainter, and each step of 5 magnitudes corresponds to a factor of 100 in actual brightness, so the scale compresses enormous ranges into small numbers. A genuinely dark night sky, no moon, no cities within 100 miles, high altitude, clear air, the sort of sky most people alive today have never actually seen, comes in at about 22 magnitudes per square arc second. That is the darkest natural sky available on this planet, and it is not perfectly dark even then, because of faint air glow in the upper atmosphere and sunlight scattering off dust in the solar system. The Kepler sky, the one the shell argument predicts, the seamless surface of stellar material in every direction, would come in at about -10, 22 to -10, 32 magnitudes, and because every 5 magnitudes is a factor of 100, 32 magnitudes is a factor of roughly 10,000 billion, 10 to the 13, 10 trillion. Now let me try to make that a quantity rather than a piece of notation, because you cannot feel a number with 13 zeros by being told it. A factor of 10 trillion is the difference between 1 second and about 320,000 years. If a second is what we actually observe, then the prediction is the entire span since our species existed in anything like its present form, several times over, or take it as mass. A factor of 10 trillion is roughly the difference between a single grain of sand and a mountain a kilometre high. Not a big rock, a mountain, or take it in your hand. The light entering your eye from the dark sky at night is a genuinely tiny trickle of photons. The prediction says that trickle should have been a flux so intense that the sky would function as a furnace wall. If you could hold up a thermometer under the predicted sky, it would climb until it read the temperature of the sun's surface, and it would stay there, day and night, at every point on the Earth, forever. There is no version of this in which the discrepancy is a modelling subtlety. When a physicist tells you a prediction failed by a factor of 2, that is a serious problem. A factor of 10 is a crisis. This is a factor of 10 trillion, from an argument that has no moving parts, based on an observation available to anyone with a functioning retina, and it gets stranger when you notice what is not wrong. The individual pieces of the argument are all fine. Light does fall off as the inverse square. We use that every day, in photography, in radio engineering, in the design of every telescope ever built. Volume does grow as the cube of radius, and the surface area of a sphere does grow as the square. Stars do exist in enormous numbers. Matter is spread through the universe in a way that, once you average over large enough regions, really is remarkably uniform. We have measured this to considerable precision, and the universe is smoother on the larger scales than almost anyone expected. Not a single ingredient of the paradox is in doubt. So the failure is not in the arithmetic. It is in one of the 2 assumptions that the arithmetic was hanging from, that the universe is unlimited in extent, and that it has been running long enough for the light to arrive. And notice that those are not really separate assumptions. They are the same assumption wearing 2 coats, because light takes time to travel, and so a limit on how long light has been travelling is functionally a limit on how far away the visible universe extends. This is the point where the darkness stops being an absence and becomes a piece of data, and I want to slow down here, because this is the idea I would most like you to leave with tonight, and it is easy to hear it as a poetic flourish when it is in fact a literal description. Pick a patch of black sky, any of them. Look into the part where there are no stars, a genuinely empty-looking gap between two bright points, the kind of place your eye slides across without registering. That gap is not empty. In almost every case, if you could see far enough along that line, there is something there. There are galaxies along that direction. There are, in all likelihood, hundreds of thousands of them, stacked one behind another out to distances that make the word distance feel inadequate. We have proved this, more or less directly, and in the most beautiful way. In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky in the constellation Ursa Major that was chosen specifically because it appeared to contain nothing at all. It was a piece of sky about the size of a grain of sand held at arm's length, selected for its emptiness. They left the shutter open for 10 days. What came back was around 3,000 galaxies in that single grain of sand, most of them never seen before, some of them so distant that their light had been travelling for well over 90% of the age of the universe, and the deeper versions of that experiment, done later with better instruments and longer exposures, kept finding more. The blank patch was not blank. It was crowded. It looked blank because the light arriving from it was too faint and too spread out for a human eye, or a short exposure to accumulate. So the darkness between the stars is not a region where the universe stops. It is a region where the universe continues, and where light is genuinely coming from, and where that light either has not finished travelling or is arriving in quantities too small to see. Here is the sentence, and I would like it to stay with you. The darkness is not empty. It is unfinished. Every black gap overhead is a direction in which light is still on its way. The sky is not a picture of the universe. It is a delivery in progress, and most of it is late, and the blackness is precisely the portion that has not been delivered yet. When you look at the night sky, you're not looking at emptiness with some light in it. You're looking at a partially completed image, one that has been filling in, pixel by pixel, for 13.8 billion years, and which is nowhere near finished, and which the universe does not have the resources to finish. I want to add one more layer to that, because there is a version of this that is even less intuitive, and it concerns what your eye is actually doing when it reports darkness. Your retina is a photon counter, and it is a remarkably good one. Under ideal conditions, a dark-adapted human eye can register a flash of a handful of photons. That is close to the physical limit. You cannot detect less than one photon, and we are operating within an order of magnitude of that. Human night vision is not a crude instrument. It is one of the most sensitive detectors that biology has ever produced, and it still reports the sky between the stars as black, not dim, black, indistinguishable from the inside of a sealed box. That is worth pausing on, because it means the light arriving from those directions is not merely faint, it is below the threshold of a detector operating near the quantum limit. The photons from those thousands of distant galaxies in every grain of sand patch of sky are arriving at a rate so low, spread over so much area and so much time, that a device capable of noticing individual quanta of light cannot accumulate enough of them to produce a sensation. When astronomers photograph those regions, they are doing the one thing your eye cannot: waiting. A retina integrates for a fraction of a second and then discards and starts again. A telescope with a cooled detector can hold the shutter open for 10 days and let the photons pile up. The difference between a black sky and 3,000 galaxies is not the presence of light. It is patience. That reframe is doing something specific to the paradox, and it is worth naming. We started with a problem. The sky is darker than it should be. We now have the beginnings of an answer. Perhaps the sky is dark because the light has not got here yet. Perhaps the shells are all out there, faithfully contributing their equal portions exactly as the geometry demands, and we are simply seeing only the nearest few because the rest are still in transit. That is a real answer. It is, as far as it goes, correct. It is the answer that a great many popular explanations give, and then they stop. But I want to flag something now, because we will come back to it, and it is the thing that makes this subject genuinely unsettling rather than merely clever. If the only problem were transit time, then the darkness would be temporary. Wait long enough and the light arrives. Wait long enough and the sky fills in, shell by shell, exactly as we watched it fill in a few minutes ago, and eventually the prediction comes true and the sky is white. It never happens. Not in any amount of time. Not if you wait 10 trillion years. Not if you wait 10 to the 50. The sky will never fill in, and the reason has nothing to do with how far the light has travelled. And when you understand that reason, the darkness overhead changes character completely, from a delay into something much closer to a verdict. Before we get there, though, we owe 200 years of very intelligent people the courtesy of taking their answer seriously. Because de Chaiseau and Olbers both proposed a solution to this, and it is the same solution almost everyone proposes, and it is the one you have probably already thought of yourself. If the light is out there and it is not reaching us, then something must be stopping it. Something must be in the way. That is the instinct, and it has been the instinct for 3 centuries, and it is worth understanding exactly how it dies, because the manner of its death is one of the most quietly ruthless arguments in physics. The proposal is simple. Space is not perfectly transparent. There is material out there, dust, gas, thin clouds of matter drifting between the stars, and light from very distant sources has to cross an enormous amount of it before reaching us. Along the way, some of that light gets absorbed. The further the source, the more material in the way, and the more of its light is lost. Beyond some distance, effectively nothing gets through at all, and the sum that was supposed to run away to infinity is cut off at a finite value, and the sky is dark. De Chaiseau proposed this in 1744. Olbers proposed it again in 1823, and the first thing to say is that the raw observation behind it is entirely correct. There really is dust between the stars. We can see it. Look at the Milky Way on a good night, and you will notice dark lanes running down the middle of the bright band. Those are not gaps in the stars. They are clouds of dust blocking the light of stars behind them. The coal sack, the Horsehead, the great rift that splits the summer Milky Way lengthwise. All of them are obscuring material, and there is a great deal of it. Interstellar dust is real, it absorbs starlight, and it reddens what it does not absorb, and astronomers spend a significant amount of effort correcting for it. So the ingredient exists. The proposal is not fantasy. It fails for a reason that neither de Chaiseau nor Olber could have known, because the physics that kills it had not been written yet. Let me put you inside the failure, because it is easier to feel than to state. You are a photon. You have just left the surface of a star in the eternal, infinite universe that this model describes, and you are travelling outward at the only speed you know. Ahead of you, at some enormous distance, is a cloud of dust, the barrier that is supposed to keep the sky dark. You reach it. You strike a grain, a speck of carbon and silicate, perhaps a fraction of a micrometer across, and you are absorbed. You are gone. From the point of view of anyone waiting downstream, you never arrived, and the model has worked exactly as advertised. But you did not vanish. You deposited your energy into that grain, and the grain is now very slightly warmer than it was, immeasurably warmer, a ludicrously small amount, and then the next photon arrives, and the next, and the next. And here is the thing about this universe. It has always existed, and it is infinite, and photons have been arriving at that grain from every direction, without interruption, forever. The grain has no way of getting rid of that energy except by radiating it away again. So it warms. Over 1 million years, over 1 billion, over 100 billion, it climbs. First it glows in the infrared, invisibly, a dull warmth. Then it begins to shine at the red end of the visible band, then orange, then it is white hot, and it goes on climbing until it is radiating away exactly as much energy as it absorbs, which is another way of saying until it is exactly as hot and exactly as bright as the stellar surfaces that have been feeding it. At that point, the grain is not blocking anything. It has become another star as far as your eye is concerned, a source of light at stellar surface temperature, sitting precisely where the barrier was supposed to be. The dust cloud that was going to save the paradox has been converted, by nothing more exotic than patience, into more sky. This is thermodynamics, and it is implacable. You cannot absorb energy indefinitely without doing something with it. In a universe of unlimited age, every absorber reaches equilibrium with the radiation falling on it, and at equilibrium it emits what it takes in. There is no material in existence, real or imagined, that can absorb starlight forever and stay dark. Dust does not remove light from the universe. It delays light, and it changes the wavelength, and it moves the light around. It cannot destroy it, because energy does not work that way. That is the sentence I would keep from this section. You cannot hide light. You can only postpone it. And notice what makes this argument so hard to wriggle out of. It does not depend on what the absorbing material is made of. You can propose any substance you like. You can invent one. As long as it absorbs light and obeys the conservation of energy, the argument applies to it. There is no material escape from this problem, and there never was. Now, there is a modern version of this same instinct that I hear constantly, and I want to address directly, because it is more sophisticated, and it is still not the answer. The modern version says, the universe is expanding, so light from distant sources is redshifted. It loses energy on the way. Very distant light gets stretched so far into the red and the infrared that it drops out of the visible band entirely, and therefore contributes nothing to the brightness of the night sky. The expansion is what keeps the sky dark. This is much better than the dust idea, and it is partly true, and it is the answer you will find in a lot of textbooks, including, for a long time, some quite good ones. Redshift is real. Expansion does drain energy out of light in transit. The contribution of the most distant sources really is reduced by it. The trouble is that when you do the calculation, redshift turns out to be a supporting actor. It is not carrying the scene. If you took our universe and switched off the expansion, froze it, kept everything else the same, kept the finite age, kept the stars burning for the time they burn, the sky would be very slightly brighter than it is now, and it would still be black, overwhelmingly black. The darkness barely notices whether the universe is expanding, which is a genuinely surprising result, and it is the central contribution of the cosmologist Edward Harrison, who spent much of his career on this question, and eventually wrote the definitive book about it. Harrison's point, made repeatedly and largely ignored for years, was that generations of astronomers had been attributing the dark sky to redshift, when redshift is a minor correction to an effect that is dominated by something else entirely. It is worth saying why the redshift explanation became so entrenched, because it is a good example of an answer being adopted for reasons that have nothing to do with whether it is correct. Expansion was discovered in the 1920s, and it was enormous news. It reorganized cosmology completely, and it happened to arrive with a built-in mechanism for draining energy from distant light, at a moment when the profession had an unsolved problem that looked exactly like a shortage of distant light. The fit was so tempting that it was accepted without anyone doing the sum carefully, and once it was in the textbooks it stayed there, because textbooks copy each other. Harrison's contribution was, in a sense, unglamorous. He went back and did the arithmetic that everyone had assumed someone else had already done, and he found that the effect being credited with the answer was contributing a modest correction, while the effect actually responsible, that stars burn out, had been sitting unexamined since Kelvin raised it in 1901. That is a more common story in science than the popular version admits. The wrong explanation is often not stupid. It is usually a real effect that points in the right direction, adopted at the right moment, and never checked for magnitude. Let me clear away 2 more escape attempts quickly, because they were serious proposals by serious people, and they both fail in instructive ways. The first is the hierarchical universe. In the early 20th century, a Swedish astronomer named Carl Charlier developed a picture in which matter is arranged in a nested hierarchy. Stars in clusters, clusters in galaxies, galaxies in bigger groups, and so on without end, with the density dropping at every level. If matter is distributed like that, the shell argument breaks, because the average density is not constant as you go outward. It falls. Charlier's universe can be infinite and still have a dark sky. It is a clever solution, and it was taken seriously for decades. It fails observationally. When we finally got surveys large enough to test it, mapping hundreds of thousands and then millions of galaxies and measuring how their clustering behaves as a function of scale, the universe turned out to become smooth above a certain size, somewhere around 300 million light-years. Below that scale, matter is beautifully structured, arranged in filaments and clusters and enormous empty voids. Above it, the structure stops getting bigger, and the universe becomes as uniform as anyone could ask for. There is no endless hierarchy. The nesting has a top. The second failed escape is star blocking, which we have already touched on. Near stars do hide far ones, and this does cap the sky's brightness at a finite value instead of an infinite one. But the cap is the surface brightness of a star, which is precisely the disaster we were trying to avoid. Star blocking does not darken the sky. It just stops the prediction from being infinitely absurd and leaves it merely catastrophically wrong. So take stock of where that leaves us. Something in the way does not work, because absorbers heat up and glow. Expansion does not work, because it is a small correction. Fractal structure does not work, because the universe smooths out. Overlapping stars do not work, because the ceiling they impose is the thing we're trying to explain away. Every route that keeps the universe infinite and eternal has now closed. Every single one. Which means the assumption that has to give is one of the two we have been protecting since the beginning, and by now you can probably see which one it is going to be. What I find remarkable is not that the answer was hard to find. It is who found it first, and where they published it, and how completely everybody ignored them. Because the correct resolution of this paradox, the actual one, the one we still teach, was stated clearly and in print in 1848 by a man with no scientific training whatsoever in a document he considered a prose poem written 18 months before he died broken delirious in a hospital in Baltimore. In February of 1848, in a lecture hall in New York, a failing writer stood in front of an audience of perhaps 60 people and explained why the night sky is dark. He was right. Almost nobody in the room understood what they were being told, and the scientific community of the 19th century paid it no attention whatsoever. The writer was Edgar Allan Poe, and by this point in his life he was in a very bad way. His wife Virginia had died of tuberculosis the previous year. He was drinking. He was broke in a way that is difficult to overstate. He had spent his career being paid almost nothing for work that was already famous, and he had watched other men make money from it. He was 2 years from the end of his life, and he had decided in this condition that what he needed to do was write a complete account of the universe. The result was called Eureka, and it is an extraordinarily strange document. It runs to about 150 pages. Poe subtitled it a prose poem and asked that it be judged as a work of art, which has given generations of readers permission to skip it. It contains a great deal that is simply wrong, and a certain amount that is mystical, and it is written in the fevered, over-decorated style he used when he was not being careful. It is not a scientific paper, and Poe was not a scientist. He had no mathematics to speak of. And inside it, there is a passage that solves a problem that had defeated Kepler, Halley, de Chezaux, and Olbers. Poe's argument, stripped of his ornamentation, is this. If the stars really do continue endlessly in every direction, then the background of the sky would show us a uniform brightness, because there would be no point in that background at which a star did not exist. Since we plainly do see voids, since our telescopes find emptiness in innumerable directions, the only way to make sense of it is to suppose that the distance to that invisible background is so enormous that no ray from it has yet been able to reach us at all. Read that again, because of what it contains. No ray has yet been able to reach us. Yet. Poe has introduced time into a problem that everyone before him had treated as purely geometric. He's saying that the darkness is not a statement about what is out there. It is a statement about what has had time to arrive. The universe has an age, light has a speed. Therefore there is a horizon beyond which nothing has reached us, and the blackness between the stars is our view of the region past that horizon. That is, in essence, the modern answer. It is the first half of the resolution we still teach today, arrived at in 1848 by a man writing horror stories for magazine rates. How did he get there? Partly by taking seriously something that professionals were curiously reluctant to take seriously. That light has a finite speed, and therefore that looking outward is looking backward. That fact had been known since the 1670s, when the Danish astronomer Ole Rømer measured the speed of light from irregularities in the timing of Jupiter's moons. Every astronomer in Europe knew it. Almost none of them had applied it to the darkness of the sky, because they were still working inside a picture of an eternal universe, and in an eternal universe a finite light speed does not save you. You can always argue that the light left long enough ago. Poe's move was to allow the universe itself to have a beginning, a proposition that was theologically loaded and scientifically unfashionable, and that he had no evidence for whatsoever. It should be said clearly that he also got a great deal wrong, and that Eureka is not a work of physics. He proposed a universe that began as a single primordial particle and expanded outward, which sounds prophetic until you read what he does with it, at which point it becomes clear he is doing metaphysics with a scientific vocabulary. Poe did not deduce the correct answer. He guessed it, brilliantly, for reasons that were partly aesthetic. But he guessed it, in print, a century before the professionals arrived, and the passage is unambiguous. Nobody listened. Eureka sold badly, was reviewed as an eccentricity, and dropped out of sight. Poe died the following year in Baltimore, delirious, in circumstances that have never been satisfactorily explained. The paradox remained, in the professional literature, unsolved. The next person to get close was as far from Poe on the respectability scale as it is possible to be. In 1901, William Thomson, Lord Kelvin, the most decorated physicist in Britain, the man the temperature scale is named after, published a paper that did the calculation properly. Kelvin's contribution was to take the finite lifetime of stars seriously. Poe had introduced finite travel time. Kelvin introduced finite burning time, which turns out to matter even more. His reasoning was that stars do not shine forever. They have a supply of energy and they use it up. He did not know about nuclear fusion. Nobody did in 1901, and Kelvin's estimates of the sun's lifetime were badly short because of it. But the principle survives regardless of the mechanism. If each star shines for only a limited period, then at any given moment only the stars within a certain distance can be contributing light to your sky, because the ones further out either have not had their light arrive yet, or have already burned out and gone quiet. Kelvin worked out roughly how far you could see under those conditions, and concluded correctly that the sky would be extremely dark. He had, in 1901, essentially the complete modern answer, and he was ignored too. The paper sank almost without trace. It was not disputed. It was simply not read, or not connected to the paradox by the people who came after. For most of the 20th century, astronomers continued to explain the dark night sky by pointing at the expansion of the universe and the redshift, which we have already established is a minor effect. The correct answer had been in the literature since 1901, and in a prose poem since 1848, and the field went on giving the wrong explanation for another 60 years. There is a pattern in this history that I think is worth naming, because it repeats in a way that is almost systematic. In each case, the obstacle was not a missing observation, and it was not a missing calculation. It was a missing permission. Kepler had everything he needed except permission to think of the universe as having an age. Halley had the geometry available and did not think to sum over shells. De Chazot did the sum correctly, and then reached for a physical medium to absorb the answer, because the alternative was a cosmos with a starting date. Olbers did the same thing 80 years later. Poe was able to solve it precisely because he was not a professional and had no institutional commitment to an eternal universe. He was free to say something unrespectable. Kelvin was respectable enough to say it, and was simply not heard. The thing standing between the human race and this answer for 3.5 centuries was not data. It was a background assumption so deeply held that the people holding it could not see it as an assumption at all. Everyone knew the universe had always existed, in the way that everyone knows things that have never been examined. And because that assumption was invisible, the darkness overhead could not be read, because reading it required treating the assumption as a variable. I do not think we have grown out of this. Every generation has a small number of these, propositions so obviously true that questioning them does not occur to anyone, and which turn out to be the thing blocking the answer to a question everyone can see. It was Edward Harrison who eventually put the whole thing together, starting in the 1960s and continuing for the rest of his career. Harrison did the modern calculation, established quantitatively that finite age and finite stellar lifetimes dominate, and that redshift is a small correction, dug Kelvin's forgotten paper out of the archives and gave him proper credit, took Poe seriously enough to quote him at length, and wrote a book called Darkness at Night that is still the standard treatment. If you want one person to attach to the resolution of this paradox, it should probably be Harrison, and almost nobody outside cosmology has heard of him. So here is the shape of the history, and I think it is worth pausing on before we go into the answer itself. A problem that anyone can see, visible from every point on the Earth's surface for the entire existence of our species, was correctly diagnosed by a bankrupt fiction writer in 1848, correctly calculated by the most eminent physicist in Britain in 1901, and then not properly assimilated by the scientific community until the 1960s. 350 years from Kepler to Harrison, and the entire time, every night, the evidence was on display above every city and every field on the planet, which should make you wonder what else is currently in plain view, not hidden, not classified, not buried in an inaccessible journal, but simply overhead and unread, because we have not yet thought to ask what it is a measurement of. So let us finally do the thing 3.5 centuries of people were building toward. Let us take the darkness seriously as a measurement and ask what quantity it measures, because it turns out to be measuring two different quantities at once, and only one of them is the one you would guess. The universe began, and the sky above your head is where you can read that off. Let me state the first half of the resolution as plainly as I can, and then take it apart. The universe has a finite age. The best current measurement puts it at about 13.8 billion years, and that number comes from several independent methods that agree with one another to within 1% or so, which is a remarkable state of affairs for a quantity nobody could even define a century ago. Light travels at a finite speed, therefore there is a maximum distance from which light could possibly have reached us. The distance light can cover in the time available. Beyond that distance there is universe. There is almost certainly a great deal of it, but its light is still in transit. It has not arrived. It has never arrived, at any point in the history of this planet, and for most of it, it never will. That boundary is called the cosmological horizon, and it is not a wall. Nothing happens there. If you travelled to a galaxy near the edge of what we can see, you would find an ordinary region of space with its own horizon drawn around it, and from there you would see a large amount of universe that is invisible from here. The horizon is not a property of space, it is a property of the observer, and every observer has their own, and it moves with them. So when Kepler proposed a dark wall enclosing the stars, he was not wrong about there being a boundary. He was wrong about what kind of boundary it is. There is an edge to what we can see, and it is real, and it is measurable. It is simply an edge in time, wearing the appearance of an edge in space, because looking outward and looking backward are the same operation. That is the first layer, and it does exactly what it needs to do. The shell argument required an unlimited number of shells to sum. Finite age caps the number of shells, the sum is cut off, and the answer comes out finite instead of catastrophic, and the sky is allowed to be dark. Now, one detail here confuses almost everyone the first time, so let me deal with it. If the universe is 13.8 billion years old, you would expect the observable region to be 13.8 billion light-years in radius. It is not. It is about 46 billion light-years in radius, 93 billion across, which sounds like a violation of the speed limit. It is not a violation, because the speed limit applies to things moving through space, and this is space itself expanding. The light we are receiving now from the most distant sources was emitted when those sources were much closer to us than they are today. The light spent 13 billion years crossing a gap that was growing underneath it the whole time, like walking up an escalator running the wrong way, and by the time it arrived, the object that emitted it had been carried much further out. So the light is 13.8 billion years old, and the thing that emitted it is now 46 billion light-years away, and both statements are true simultaneously. There is something else in that picture that I want to draw out, because it changes what a telescope is. Because light takes time, distance and age are the same axis. When you look at the moon, you're seeing it as it was a little over a second ago. The sun, 8 minutes. The nearest star, 4 years and change. The centre of our galaxy, 26,000 years. Light that left when the last ice age was at its worst. Andromeda, 2.5 million years, which is roughly the age of the earlier stone tools. Push further and it stops being a curiosity and becomes a method. The most distant galaxies observed by the newest telescopes are seen as they were within a few 100 million years of the beginning, which means we're not inferring the early universe from theory. We are watching it, directly. It is on the sky right now, in the same field of view as everything else, layered by distance into layers of age. There is no other science that works this way. A geologist digs down through rock to reach the past, and can only sample the small part of the planet they can physically reach. A historian works from documents that survived. Astronomy is the only field in which the past is simply visible, where you can point an instrument at the sky and receive, unmodified, a signal emitted before the Earth existed, and where the deeper you look the earlier you see, automatically, as a consequence of geometry, which means the darkness between the stars is not only a measurement of the age of the universe, it is the boundary of the archive. It marks where the record we can access runs out, and everything inside it is readable, and everything past it is not. Here is the phrase I want to give you for the first layer of the answer, and it is going to come back at the end of tonight with a different meaning attached. The sky is a clock. The amount of darkness overhead is a direct readout of how long the universe has existed. That is not a metaphor. It is a functional relationship. More time means more shells have had their light arrive, which means a brighter sky. A younger universe would have a darker sky than ours. An older one would have a brighter sky. The specific degree of blackness above your head at this moment is the number 13.8 billion, expressed in a form your eyes can take in without any instruments at all. You've been reading a clock your entire life without knowing it was a clock. Let me put a thought experiment on this, because it makes the mechanism concrete. Suppose you could run the universe forward. Not change anything else. Same stars, same physics, same density, just let it run. What happens to the sky? At first, exactly what you would expect. More distant light arrives. Shells that were still in transit complete their journeys. The faint background glow between the stars creeps upward, very slowly, and the sky brightens by an amount no living creature would ever notice, because the timescales are enormous. And then it stops. Not because you have run out of universe, but because you have run out of something else. And this is the moment where the tidy answer we just built starts to develop a crack in it. Before we go through that crack, let us pause and stack up what we have, because we are at the midpoint of tonight, and the ground has moved several times. We began with an observation so ordinary that nobody thinks to question it. The night sky is dark. We showed that this is not what a large, old, evenly furnished universe predicts, that the inverse square law and the growth of volume cancel exactly, that every shell contributes equally, that the sum runs away, and that the prediction is a sky of stellar surface brightness in every direction, with no gaps in it at all. We measured the failure, and found it to be a factor of roughly 10 trillion, one of the largest disagreements between prediction and observation anywhere in science. We tried to save it with dust and watch thermodynamics turn the dust into more sky. We tried to save it with expansion, and found that redshift is a minor player. We tried fractal structure, and found that the universe smooths out above about 300 million light-years, and we have now arrived at the answer that Poe intuited and Kelvin calculated. The universe has a beginning, light has not had time to arrive from everywhere, and the darkness is the portion of the sky where the delivery is incomplete. That is a genuine resolution, and you could stop there with a clear conscience. Most explanations do. Here is why I am not going to. Go back to the thought experiment. We are running the universe forward, and the sky is slowly brightening as more distant light arrives. Now ask the question that Kelvin asked, and that almost nobody asks. While we are waiting for that light, what are the stars doing? They are burning. And burning is not a stable condition, it is a process of consumption. A star is a body of hydrogen converting itself to helium at an enormous rate, and while it does so, it is running down a supply that does not replenish. The Sun has been doing this for about 4.5 billion years, and has roughly 5 billion left before the core hydrogen runs out, and it begins to come apart. Bigger stars are far worse. A star 10 times the mass of the Sun has perhaps 20 million years, because it burns its fuel with a profligacy that is difficult to convey. The most massive stars in the universe last a couple of million years, less time than our own species has existed. So the shells are not patient contributors waiting their turn to deliver an eternal quantity of light. Each shell is a collection of objects with a working life, and that working life is short compared to the times we're discussing. By the time light from a very distant shell reaches you, the stars that emitted it have long since stopped emitting. You're receiving a signal from sources that no longer exist in the state that produced it. That changes the sum completely. It means the sky is not filling in gradually toward a bright limit. It means there is a hard ceiling on how much light the universe can ever put into the sky, and the ceiling is set not by how long we wait, but by how much fuel there is. And when Harrison did that calculation properly, he found something that reframes this entire subject. It is not the finite age of the universe that is primarily responsible for the darkness of your sky. It is something more permanent and considerably less comfortable, and it means the sky would be dark even if Kepler had been right about everything. Give the universe unlimited time. Give it infinite extent. Give Kepler everything he was afraid of. The sky stays dark. That is Harrison's result, and it is the part of this story that almost never gets told, and it is the reason I did not let us stop at the previous answer. Here is the calculation in the form you can carry. To raise the radiation filling space up to the surface brightness of a star, to actually produce the Kepler sky, the stars of the universe would have to shine, at their present rate, for something on the order of 10 to the 23 years, That is the number that comes out of the arithmetic. 100,000 billion years. The actual working life of a star is on the order of 10 to the 10 years, 10 billion. The gap between those two figures is a factor of about 10 to the 13, 10 trillion. And I want you to notice something about that number, because we have met it already tonight. It is the same factor by which the observed sky falls short of the predicted one. That is not a coincidence. It is the explanation. The sky is 10 trillion times too dim because the stars have been running for 10 trillion times too short a period, and they always will have been, because they do not last. Let me try to make the two timescales sit next to each other, because both of them are meaningless as spoken words. 10 billion years is a length of time that already breaks intuition. The Earth is 4.5 billion years old. Multicellular life has been around for something like 600 million years, which is about 6% of a stellar lifetime. Every mountain range you can name has formed and eroded inside that window several times over. 10 billion years is, roughly, the total operating life of a well-behaved star like the Sun, from ignition to the end of core burning. Now, 10 to the 23 years is that entire span, repeated 10 trillion times. If you compress the 10 billion year lifetime of the Sun down to a single second, then the time required to fill the sky with starlight would still be over 300,000 years at that compressed rate. The stars would need to burn at full output for that long. They get 1 second. And this is where it becomes genuinely permanent rather than merely a matter of waiting, because the shortfall is not about scheduling. It is about supply. Stars run on nuclear fusion, and fusion is efficient by the standards of anything else we know, and it is still not very efficient in absolute terms. When 4 hydrogen nuclei fuse into helium, about 0.7% of the original mass is converted into energy. Not 7%, 0.7%. The other 99.3% stays as matter, and a star does not even get to use all of its hydrogen. Only the material in the hot core participates, which for a star like the Sun is a modest fraction of the total. The rest sits in the outer layers, never reaching the temperature required, and eventually gets thrown back out into space when the star dies. So take the total amount of ordinary matter in the universe. Assume, generously, that all of it eventually finds its way into stars, which it does not. A great deal of it is diffuse gas that will never collapse into anything. Assume all of them burn as much of their hydrogen as they can. Convert 0.7% of that mass into radiation. That is the entire light budget of the universe. That is every photon that stars will ever produce, from the first one that ignited to the last dim red dwarf still glowing 100 trillion years from now. It is not enough. It is not close to enough. It falls short of filling the sky by that factor of 10 trillion, and no amount of time fixes it, because time is not the constraint. There is simply not enough hydrogen in existence to light the sky, and there never was, and there never will be. This is the second layer, and I want to let it land properly. We tend to picture the universe as a lit place. There is light in it, a great deal of light, coming from an enormous number of sources, and the dark parts are the bits between the lamps, and if you had enough lamps you would fill it in. That picture is upside down. The universe is a dark place in which a very small quantity of matter is, temporarily, undergoing a reaction that produces light. The light is not the background condition with darkness interrupting it. The darkness is the background condition, and the light is a brief, thermodynamically expensive, self-limiting exception that is currently in progress and will not be repeated. Think about what a star actually is, in that framing. It is a fuel tank that has been ignited. It has a fixed amount in it. It is being consumed at a rate that is not adjustable, and when it is gone there is no mechanism anywhere in physics for putting it back. Every photon that has ever reached your eye from a star was purchased with a permanent, irreversible expenditure of the universe's total supply of nuclear fuel. The sunlight falling on your face on a summer afternoon was paid for out of an account that does not receive deposits, and the account is not large. That is the thing that reframes it. If the supply were effectively unlimited, the finite lifetime of an individual star would not matter much. One goes out, another lights, the sky fills in eventually. But the supply is bounded, and we can put a number on how far it goes, and the number says it covers about 1/10 trillionth of the sky. It is worth being concrete about where the fuel actually goes, because the inefficiency compounds at every stage and the compounding is the story. Start with the gas. Most of the ordinary matter in the universe is not in stars at all. A large fraction of it is diffuse gas spread through the space between galaxies, too thin and too hot to collapse into anything, and it will stay that way. That material is never going to burn. It is on the balance sheet, but it is not available. Of the gas that does make it into a galaxy and does collapse into a star, only the core participates in fusion. In a star like the Sun, the region hot enough for hydrogen burning is a modest fraction of the total mass. The outer layers are along for the ride. When the core hydrogen is exhausted, the star does not simply keep going on the rest. It restructures, swells, and eventually sheds much of its outer material back into space, still mostly hydrogen, unburned, and of the mass that does fuse, 0.7% becomes light. The rest becomes helium, which mostly sits there. Helium can burn in the cores of stars that get hot enough, but the return diminishes with each step up the periodic table, and the sequence terminates at iron, past which fusion consumes energy rather than releasing it. Stack those inefficiencies and the fraction of the universe's ordinary matter that will ever be converted into starlight is small, and ordinary matter is itself only about 5% of the total energy content of the universe, the rest being dark matter and dark energy, neither of which shines at all. So the light budget is a small fraction of a small fraction of a small fraction. That is the account the sky is drawing on, and it is why the shortfall is 13 orders of magnitude rather than 2 or 3. So the darkness overhead is not a delay. It is a balance. It is the universe's fuel gauge, and it is reading almost empty, and it has been reading almost empty since the first star lit, and it will read almost empty until the last one goes out. Which means, when you take the two layers together, the darkness is doing double duty as a measurement. The first layer told us that the universe had a beginning, that there is a horizon in time, and the black patches are places whose light is still on its way. The second layer tells us something harsher, that even if you removed the horizon, even if you gave the light unlimited time to arrive from an unlimited universe, it would still not fill the sky, because there is not enough of it in existence. Those two facts together close the paradox properly. The sky is dark because the universe is young, and the sky would be dark anyway because the universe is poor. And there is a strange kind of consolation available here, which I want to offer before we go any further, because the next part of tonight is going to take it away again. We are living during the era when the fuel is burning, not before it, when there was nothing to see, and not after it, when there will be nothing left to see with. Right now, at this specific and extremely narrow moment in the operating life of the universe, there are stars, and there are creatures with retinas, and there is a night sky with points of light in it that can be looked at and counted and understood. That is not the normal condition of the universe, it is an interval. Now, all of that is true, and all of it is well established, and it is the answer to the question the title of tonight's video asks. We could stop here, except that the premise we have been working from since the first minute, the premise that the sky is dark, is false. It was always false. Every direction you look genuinely does terminate on a glowing surface, exactly as the shell argument demanded, with no gaps anywhere. Kepler's blazing sky is up there tonight, covering everything, arriving continuously from every direction at once, passing through the walls of the room you're sitting in and through your body while you listen to this. You cannot see it, and the reason you cannot see it has nothing whatsoever to do with cosmology. In 1964, 2 radio astronomers in New Jersey spent the better part of a year trying to get rid of the light that fills the universe, on the assumption that it was a fault in their equipment. Arno Penzias and Robert Wilson were working at Bell Telephone Laboratories in Holmdel, with an instrument called the Holmdel horn antenna, a large aluminium horn built originally for bouncing signals off early communication satellites. They had been given time to use it for radio astronomy, and they wanted to measure faint emission from our galaxy, which required knowing exactly how much noise their own system produced so they could subtract it. There was more noise than there should have been, a persistent hiss, low but unmistakable, that would not go away. What follows is one of the great sequences of methodical elimination in the history of science, and it is funny in a way that only becomes funny in retrospect. They checked the electronics. They checked the joints in the horn and covered the riveted seams with aluminium tape. They pointed the antenna at New York City to see whether urban interference was responsible. It was not. They considered whether residue from a 1962 high-altitude nuclear test was still contaminating the upper atmosphere. The timing did not work. And they discovered that a pair of pigeons had taken up residence inside the horn, and coated the interior with what Penzias diplomatically described in print as a white dielectric material. They evicted the pigeons, they cleaned the horn. The pigeons came back and were dealt with more permanently, which Penzias later said he felt bad about. The hiss remained, exactly as before, and it had two properties that ruled out every remaining local explanation. It did not vary with the time of day, which meant it was not coming from the sun or from anything else that rose and set, and it did not vary with the direction the antenna was pointed. Not at all. Whichever way they aimed the horn, the same signal, at the same intensity, to the precision they could measure. Something was arriving from every direction in the sky with equal strength. 30 miles away at Princeton, a group led by Robert Dick was building an antenna to look for exactly that. Their reasoning was theoretical. If the universe had begun in a hot, dense state, it would have been filled with radiation, and that radiation should still be present, cooled by expansion into the microwave band. They were constructing an instrument to hunt for it. A phone call put the two groups in contact, and Dicker reportedly hung up and told his colleagues that they had been scooped. The two papers were published together in 1965. Penzias and Wilson's is a model of understatement. It reports an excess antenna temperature of about 3.5 Kelvin and makes essentially no cosmological claims. The companion paper from the Princeton group explains what it means. Penzias and Wilson received the Nobel Prize in 1978. What they had found is called the cosmic microwave background, and here is what it actually is. For the first 380,000 years after the beginning, the universe was hot enough that atoms could not hold together. Electrons were free, not bound to nuclei, and free electrons scatter light ferociously. A photon could not travel any meaningful distance before being deflected. The universe was opaque, not dark, but opaque, like the interior of a fog bank lit from within, blazing with radiation that could not get anywhere. Then, at about 380,000 years, expansion had cooled things to roughly 3,000 Kelvin, and something abrupt happened. Nuclei and electrons combined into neutral atoms. The free electrons disappeared into those atoms, and the fog cleared, all at once, everywhere. The photons that had been ricocheting around suddenly found nothing in their way, and they have been travelling in straight lines ever since. That moment is called recombination, and the shell of it that we can see is called the surface of last scattering. It is not a place. It is a time, drawn on the sky as a sphere around us, because in every direction we look there is a distance at which we are seeing that moment. Now hold that next to the paradox we have been working on all night, and see what happens. The prediction was that every line of sight must terminate on a glowing surface. It does. Every single one. Look in any direction whatsoever, into the darkest, emptiest-looking patch of sky you can find, between the stars, between the galaxies, into the deep field where nothing appears to be at all, and follow that line far enough, and it does not run out into nothing. It ends on the surface of a last scattering, on a wall of light at 3,000 Kelvin blazing in the visible band, arriving from every direction with no gaps whatsoever. Kepler's sky is real. It is up there right now. His prediction was correct in every particular except one. The surface is not the surface of a star, it is the surface of the universe itself. At the moment it became transparent, and it surrounds us completely. The only thing that has changed since that light was released is the wavelength. In the 13.8 billion years it has been travelling, space has expanded by a factor of about 1100, and the light has been stretched by the same factor. What left as visible orange-white light at 3000 Kelvin has been drawn out until it arrives as microwaves at 2.725 Kelvin, a little under 3 degrees above absolute zero. That is the entire difference between the blazing sky Kepler feared and the black sky you see. Not the presence or absence of light, a stretch factor of 1100, which has moved the light out of the narrow band that human eyes happen to respond to. Let me put you under it. You're lying on your back outside in the same field where we started tonight, and I am going to swap your eyes for microwave eyes. Nothing else changes. Same field, same night, same air. The sky fills in, not with stars, with a surface. It comes up all at once and it is everywhere. No constellations, no gaps, no black. It is smooth to about 1 part in 100,000, which is smoother than anything you have ever seen, smoother than still water, smoother than a manufactured lens. It arrives from the horizon and from directly overhead with the same intensity. It is behind the moon. It is behind the trees and through the trees and through the roof of the house you came out of. It is passing through your hand if you hold it up, and it does not cast a shadow, because there is no direction it is not coming from. The stars are still there, but they have stopped being the sky. They are pinpricks scattered on the front of an unbroken sheet of light that goes all the way around and closes behind you, and you are inside it, not looking at it from outside, inside it, with the light passing through you continuously. About 411 photons of it are in every cubic centimetre of space around you at this moment, which means the volume of your body contains a number of these photons, with a great many zeros after it, and every one of them was released 380,000 years after the universe began, and has been travelling without interruption since, and is ending its journey in you. For anyone old enough to remember analog television, when you tuned an old set to a channel with no station and got that grey snow, roughly 1% of that noise was this: the oldest light in the universe, arriving in a living room, being rendered as static on a television screen. There is a detail about that wall of light that I think is the most beautiful fact in observational cosmology, and it concerns how perfect it is. When instruments measured the spectrum of the microwave background properly, the amount of energy at each wavelength, the result matched the theoretical curve for a body radiating at a single temperature so precisely that the error bars on the measurement were smaller than the thickness of the line drawn on the graph. When that result was first presented at a scientific meeting, the audience gave it a standing ovation, which is not something that happens to graphs. That matters because a perfect thermal spectrum is a fingerprint of equilibrium. It is what radiation looks like when it has been in intimate contact with matter, exchanging energy back and forth freely, long enough to settle. You cannot fake it with a mixture of stars or dust or any assembly of sources. Those produce lumpy spectra with features in them. The only way to get a curve that clean is for the whole system to have been hot, dense, and thoroughly mixed. The microwave background is not evidence that the early universe was hot in the sense of a suggestive clue. It is a direct thermal measurement of a state the universe was in, taken from inside it. So the sentence we have been carrying since the beginning turns out to be true. Every line you look along must end on the surface of a star. It was never the absurdity we treated it as. It is a description of the sky above you. The line ends on a surface. The surface is glowing. It fills every direction, and the darkness we have spent all night explaining is not a property of the universe at all. It is a property of the aperture we are looking through. Human vision covers a range of wavelengths spanning less than a single octave, from about 400 nanometers to about 700. On a piano, that is not the keyboard. It is 7 adjacent keys. The electromagnetic spectrum runs from radio waves meters or kilometers long to gamma rays smaller than an atomic nucleus, and we see a slot in the middle of it so narrow that describing it as a fraction requires scientific notation. Which raises an obvious question, and it is the last piece of accounting we need to do before the end of tonight. If the sky is full of light we cannot see, then exactly how much light is up there, in all the bands from every source added together? We can measure that now, and when you total it up the books nearly balance. Nearly. There is a discrepancy sitting in the optical band that nobody has yet fully explained, and the best measurement of it was made by a spacecraft 4 billion miles from here, from the only vantage point in history dark enough to take it. Count the photons in the universe and count the atoms, and the photons win by a factor of about 1.6 billion to 1. That is the ratio, and it is one of the most important numbers in cosmology and one of the least known outside it. For every proton and neutron in existence, every particle of every atom in every star, every planet, every cloud of gas, every human being, there are roughly 1.6 billion photons of the cosmic microwave background. By simple head count, the contents of the universe are overwhelmingly light. Matter is the trace contaminant. Everything you have ever touched, everything you have ever seen, everything anyone will ever build, is made from the impurity. I find that number genuinely difficult to hold in my head, and I think the reason is that we assume light is the thing that gets emitted, and matter is the thing that does the emitting, so matter must be the primary substance, and light the byproduct. The census says otherwise. The overwhelming majority of the particles in the universe are photons released before any star existed, and they are still here, filling every cubic centimetre of everywhere at 411 per centimetre cubed, cooling extremely slowly, and they will outnumber matter for the entire remaining history of the universe. So let us do the full accounting, because we now have the tools to answer the original question properly. How much light is there in the sky, in every band, from every source added together? Astronomers call this the extragalactic background light, and it is the integrated glow of everything outside our own galaxy. It has several components, and each one is a different chapter of cosmic history. At the long wavelength end there is the microwave background, which we have just met, and which dominates everything else in photon number by an enormous margin. Then there is the cosmic infrared background, which is starlight that was absorbed by dust inside galaxies, warmed the dust, and was re-radiated at longer wavelengths, the same thermodynamic process that destroyed the dust explanation, running at galactic scale. Then the cosmic optical background, the direct unabsorbed light of every star in every galaxy in the observable universe, added up. Then the ultraviolet background from hot young stars and quasars, and beyond that the X-ray background from accreting black holes and hot cluster gas, and at the extreme end a gamma-ray background from the most violent processes we know of. Total those up, and you have the entire light budget of the universe outside the Milky Way. It is the modern, quantitative version of the question Kepler asked, and the answer is a set of numbers rather than a blazing sky. Measuring the optical part is much harder than it sounds, and the difficulty is close to home. The problem is dust in our own solar system. There is a great deal of fine material spread through the inner solar system, debris from comets and collisions between asteroids, and sunlight scatters off it. The result is called zodiacal light, and if you have ever been somewhere dark before dawn and seen a faint cone of glow rising from the horizon along the path of the sun, you have seen it directly. From anywhere near the Earth, that scattered sunlight is far brighter than the faint background of distant galaxies you're trying to measure. It is like trying to measure the brightness of a distant candle while standing inside a lit room. You can model the room and subtract it, and people have done heroic work doing exactly that, but the correction is much larger than the signal, and everyone knows that is a bad position to be in. The solution is to leave the room, and one spacecraft has. New Horizons flew past Pluto in 2015 and has been travelling outward ever since. It is now several billion miles from the Sun, far outside the zone where the interplanetary dust is thick, in the darkest location any human instrument has ever operated from. And it carries a camera, the long-range reconnaissance imager, which can be pointed at blank sky and used to measure how much light is arriving from nothing in particular. That is what the team did. They selected fields at high galactic latitude, far from the plane of the Milky Way, chosen to minimize contamination from our own galaxy's stars and dust, and they measured the total optical light arriving from apparently empty sky, and then subtracted everything they could identify. The result reported in 2024 from 16 separate fields is a cosmic optical background of about 16.4 nanowatts per square metre per steradian, with an uncertainty of roughly 1.5 at a wavelength near 0.6 microns. Orange light, right in the middle of the visible band. The problem is what that number is compared to. If you take the deepest galaxy surveys ever made, count every galaxy in them, add up all their light, and extrapolate carefully to include the faint ones below the detection limit, you can predict how much optical background there ought to be. The New Horizons measurement comes out at roughly twice that. The excess sits at about 4 standard deviations from the expected value, which in the language of physics means suggestive but not conclusive. Enough to take seriously, not enough to announce. So there may be, in the darkest measurement anyone has ever made, roughly twice as much light as the known contents of the universe can account for. I want to be careful here, because this is exactly the kind of result that gets overstated, and the honest position is more interesting than the exciting one. Subsequent work has argued that better treatment of very faint galaxies, the ones too dim to appear individually in any survey, together with a more careful handling of instrumental systematics, can close much or all of the gap. The field has been moving toward reconciliation rather than away from it. This may well turn out to be an accounting problem rather than a discovery, and if I had to bet, that is where I would put my money, but it is not settled, and the candidate explanations, if some of the excess survives, are worth knowing. The most conservative is that there are simply more faint galaxies than we have counted, a population of small, dim systems below everyone's detection threshold, collectively contributing more than the extrapolations assume. The second is intra-halo light, stars that have been stripped out of their galaxies during mergers and now drift in the surrounding dark matter halo, unbound to anything, too diffuse to appear as a galaxy but contributing to the total glow. There is good independent evidence that this population exists. The question is how much it contributes. And the third, considerably more speculative, is that some species of dark matter particle is slowly decaying and producing optical photons as it does so, in which case the excess would not be starlight at all, but the visible signature of the invisible majority of the universe's matter. That third possibility should be flagged clearly as speculation. It is a minority hypothesis. It depends on the excess being real, and the excess may not be. There is a second way of measuring the same background that I find remarkable, because it does not involve looking at the background at all. The trick uses gamma rays from very distant sources. A high-energy gamma-ray photon travelling across the universe can collide with a much lower-energy photon of the background light, and if the energies are right, the pair converts into an electron and a positron. The gamma-ray is destroyed. This means that distant gamma-ray sources should appear dimmed at high energies, and the amount of dimming depends on how much background light the gamma-rays had to swim through on their way here. So you can measure the total light filling the universe by observing how much of it is quietly eating gamma-rays. You never look at the background directly. You infer it from the shadow it casts on something else. Several teams have done this using observations of active galaxies and gamma-ray bursts, and the results are broadly consistent with the light we can account for from counted galaxies, which is one of the reasons the optical excess is treated with caution rather than excitement. What I like about this result, regardless of how it resolves, is what it demonstrates about the paradox we have been following all night. Olber's paradox is usually presented as a historical curiosity, a puzzle from the age of powdered wigs, solved, closed, filed. It is not closed. The question Kepler asked in 1610 is exactly the question New Horizons was pointed at 414 years later. How much light is arriving from the sky, and can we explain all of it? That is a live measurement with a current disagreement in it, being argued over in journals right now, from a vantage point beyond Pluto. And the two answers stand next to each other in a way that is worth noticing. The sky is 10 trillion times darker than a naive calculation says it should be, and at the same time, in one particular band, it may be about twice as bright as our best inventory can explain. We are still not entirely sure how much light is up there, which brings us to the last movement of tonight, and to the part of this subject I find hardest to shake. We have spent this whole video treating darkness as the thing requiring explanation, and light as the normal state of affairs that has somehow gone missing. That instinct is backwards, and the universe has already demonstrated it once, in a period lasting hundreds of millions of years, during which there was no star anywhere in existence, and nothing in the sky had edges. There was a period in the history of the universe when no star had ever existed, and it lasted longer than the entire span from the extinction of the dinosaurs to the present day, several times over. Astronomers call it the Cosmic Dark Ages, and it is my favourite era in cosmic history precisely because there is nothing in it. It begins at recombination, that moment 380,000 years in, when the fog cleared and the universe became transparent, and it ends somewhere between 100 and 400 million years later, when the first stars ignited. In between there is a stretch of a few 100 million years during which the universe was transparent and full of matter and completely unlit. Picture what it contained. Hydrogen and helium, essentially nothing else, spread through space in a distribution that was almost perfectly smooth, varying from place to place by about 1 part in 100,000, which is the same ripple pattern we still read off the microwave background today. No stars, no galaxies, no planets, no dust, no heavy elements of any kind, because heavy elements are manufactured inside stars and there had never been a star. No carbon, no oxygen, no iron, no silicon. Nothing in the universe had a surface, nothing had edges. There was gas, and the gas went on in every direction without structure, and it was very slowly being pulled by gravity toward the slightly denser regions. I should be careful about the word dark, because it was not instantly black. The light released at recombination was still there, filling everything, and at first it was still visible. The universe glowed a dull red-orange everywhere at once, the colour of a cooling ember, for a while after the fog lifted. Then expansion stretched it out of the visible band into the infrared, and the glow faded, not because it was extinguished, but because it moved out of range. And there is a detail in that fade that I have never been able to stop thinking about. somewhere around 10 to 20 million years after the beginning, the background radiation had cooled to a few hundred Kelvin, which means that for a period of a few million years, the entire universe, everywhere, uniformly, with no exceptions, sat at roughly the temperature of a warm room, all of space, at once, at something close to the temperature at which liquid water is possible. There was no chemistry to take advantage of it, no carbon, nothing that could have formed anything, and it did not last. But there was an interval during which the universe as a whole was, in the most literal thermal sense, comfortable. Then it kept cooling, and the light kept stretching, and the universe went genuinely dark. Let me take you there, because I think it is worth standing in. You are somewhere in the universe about 200 million years after the beginning. There is no ground to stand on, so simply be present. The hydrogen is around you, thin and faintly warm, and it goes on in every direction without any feature you could point at. There is no up. There is nothing you could describe as a landmark, because a landmark requires an edge, and nothing here has one. Look in any direction. There is no light, not dim light, not distant light. Nothing has ever shone. In the entire universe, in every direction, out to distances that have no meaning here, there is not one object emitting visible light, and there never has been. The concept of a light source does not yet correspond to anything real, and then, somewhere in a region where the gas is very slightly denser than average, gravity finishes a job it has been working on for 200 million years. A cloud of hydrogen collapses inward on itself, and as it collapses it heats, and the heating accelerates the collapse, and at the centre the temperature climbs through 1 million Kelvin, through 5 million, and then crosses roughly 10 million Kelvin, and hydrogen nuclei begin to fuse. The first star in the history of the universe switches on, and for the first time there is a direction from which light is coming. There is a here and a there. There is such a thing as a shadow. There is, for the first time in nearly 200 million years of cosmic history, an object with a surface, and it is radiating, and the light it releases begins travelling outward into a universe where nothing like it has ever happened. Those first stars were nothing like the Sun. With no heavier elements to help the gas cool and fragment, the clouds could not break up into small pieces, so the objects that formed were enormous, many tens, possibly hundreds of times the mass of the Sun. They burned ferociously and briefly in the ultraviolet for a couple of million years, and then blew themselves apart, and in doing so manufactured and scattered the first carbon and oxygen and iron that had ever existed. Every heavy atom in your body traces back to that generation, and the ones that followed. We have never directly observed one. They are called population 3 stars, and finding them is one of the things the newest telescopes are built for. I want to stay with that first ignition a moment longer, because there is something about it that is easy to say quickly and difficult to actually take in. Every star that has ever existed was preceded by that one. Every sunrise on every planet in the history of the universe traces back through a chain of generations to an object that formed out of nothing but hydrogen and helium in a universe that never contained a light source, and the interval before it was not short. Depending on where the first collapse happened, the Dark Ages ran for somewhere between 100 and 400 million years. For comparison, the entire span from the first dinosaurs to now is about 230 million years. The universe spent something like that long, possibly longer, with nothing shining in it anywhere. It also means the universe was, for that period, genuinely without events in the sense we normally use the word. Things were happening, gas was flowing, structure was slowly assembling, gravity was doing patient work on a scale we can now simulate but not observe, and none of it produced light, so none of it can be seen. The Dark Ages are the largest gap in the observational record, and they are unobservable in principle at optical wavelengths, because there is nothing there to observe. There is one way in, and it is being built now. Neutral hydrogen emits and absorbs at a wavelength of 21 centimetres, and that signal, redshifted enormously by the expansion since, should carry a faint imprint of the gas structure during the Dark Ages and of the first sources switching on inside it. Detecting it requires radio arrays of extraordinary sensitivity in places with almost no artificial radio noise, which is why some of the most serious proposals involve building on the far side of the Moon, permanently shielded from the Earth. If it works, we will have a picture of the universe from a period when there was nothing to take a picture of. Their ultraviolet light did something else as well. It began ionizing the neutral hydrogen that filled space, stripping electrons off it again in expanding bubbles around each source, and over the next several 100 million years those bubbles grew and merged until the whole universe had been reionized. That transition is one of the last major events in cosmic history that we cannot yet observe directly, and mapping it is a live project. Now, here is why I have taken you back there, and it is not for the scenery. We have spent all night treating darkness as the anomaly. The paradox itself is framed that way. The sky should be bright. Why is it dark? What is wrong? And the answer we found is that the universe is too young and too poor to light it. But standing in the dark ages reframes the whole question, because it shows you what the universe looks like without stars, and the answer is, like that. Featureless, smooth, transparent, and completely unlit. That is not a failure state. That is the default. The stars are the interruption. They are a temporary condition brought about by gravity slowly gathering a smooth distribution of hydrogen into knots dense enough to ignite. A process that has a beginning, which we can date, and an end, which we can estimate. Before it, darkness. After it, darkness. And in the middle, an interval during which some of the matter in the universe is undergoing the reaction that produces light, and during which, on at least one planet, some of that matter has arranged itself into configurations that can look up. The night sky you see is not the universe in its normal state with some of the light missing. It is the universe during the brief window in which any of the light exists at all. Which raises the question I have been holding back since the first minute of this video, and it is the one that actually answers the title. We know why the sky is dark now. We know it is a clock and a fuel gauge and a limitation of our eyes. But none of that is the part that should unsettle you. The part that should unsettle you is what happens to the darkness next. So let me answer the question we started with, plainly and in order, and then tell you the part I have been holding back. The night sky is dark for 3 reasons, stacked. It is dark because the universe is young. Light travels at a finite speed, and the universe has existed for a finite time, so there is a horizon beyond which nothing has reached us yet, and the black patches overhead are the region past that horizon. The darkness is a measurement of the age of the universe, taken with your own eyes, requiring no instrument at all. It is dark because the universe is poor. Even with unlimited time and unlimited extent, the sky would stay black, because stars run on a finite supply of nuclear fuel and produce roughly 1/10,000,000,000th of the light required to fill the sky. That shortfall is permanent. It is not a delay, it is a balance, and it does not improve. And it is dark because your eyes are narrow. The sky is in fact blazing in every direction, with no gaps whatsoever, exactly as Kepler was afraid it would be. The surface of last scattering surrounds you completely, and is arriving through you at this moment at 411 photons per cubic centimetre. It has simply been stretched out of the slot your retina responds to, which spans less than 1 octave of a spectrum that runs for more than 20. Those 3 answers are correct and complete, and none of them is the thing worth being unsettled by. Here is the thing worth being unsettled by. The darkness is growing. For most of the 20th century, the working assumption was that expansion would gradually slow down under the collective gravity of everything in the universe. In 1998, 2 independent teams measuring distant supernovae found the opposite. The expansion is speeding up. Something making up roughly 68% of the energy content of the universe is pushing it apart, and the more space there is, the more of that something there is, so the effect compounds. The consequence is that our view is closing. Galaxies currently visible to us are being carried outward, and their recession is accelerating, and one by one they will cross a boundary past which their light can no longer reach us. Not because they have gone anywhere in particular, but because the space between us and them is growing faster than their light can cross it. The sky is a slow closing aperture, and we are inside it. Run that forward, and the picture is specific enough to describe. The Milky Way and Andromeda are gravitationally bound to each other, and to the rest of the local group, so they are not going anywhere. In a few billion years they will merge into a single large elliptical galaxy, and over a longer period the other local group members will be drawn in as well. That merged system stays. It is bound, and dark energy does not pull apart things that are bound. Everything else leaves. On timescales of order 100 billion years, every galaxy outside the local group will have receded beyond our cosmological horizon. Not faded, gone, in the sense that no signal from them can ever arrive again. The nearest galaxy cluster, the Virgo cluster, the enormous flows of galaxies we have spent decades mapping, the deep field images with their thousands of objects in a grain of sand. All of it crosses the line and stops being observable, permanently. And the microwave background goes too. It is being redshifted continuously by the same expansion that has already stretched it by a factor of 1100. Given long enough, its wavelength grows longer than any conceivable instrument could detect, and eventually longer than the scales over which an observer could even build an instrument. The oldest light in the universe, the thing that proves the universe had a hot beginning, fades below the noise floor and then below the possibility of a flaw. So picture an astronomer 100 billion years from now. They're on a planet around a long-lived red dwarf, in the merged remnant of the local group, and they are careful and rigorous and every bit as intelligent as anyone working today. They build telescopes, they look up, they see stars, their own galaxy, full of them, and beyond the edge of it, they see nothing whatsoever, no other galaxies, no redshift distance relation, because there is nothing outside the local system to measure a redshift against. No microwave background, because it is stretched below detectability. No evidence of expansion, because everything still visible to them is gravitationally bound and therefore not expanding. What conclusion would you draw from that data, done properly? You would conclude that the universe consists of a single island of stars sitting in an infinite, empty, unchanging void. You would conclude that it is static. You would find no reason to believe it had a beginning, and no evidence that anything exists beyond your own galaxy, and you would be doing good science, and every one of those conclusions would be wrong, and there would be nothing in your sky to correct you. The evidence would not be hidden or difficult. It would be absent. It would have left. This is not a fringe scenario. It is the straightforward consequence of accelerating expansion, and it was worked out in detail by the physicists Lawrence Krauss and Robert Scherer, who pointed out the uncomfortable corollary. Cosmology is not a permanent body of knowledge. It is a window. The reason we know the universe had a beginning and is expanding and contains something like 2 trillion galaxies is that we are alive during the interval in which those facts are still readable off the sky. Wait long enough, and they become unknowable, not unproven, not disputed, but genuinely unavailable to any observer, forever. We happen to have arrived during the legible period. That is not a small thing. If human beings had evolved 100 billion years later, on a planet in that merged galaxy, we would have looked up at a black sky with local stars in it, and built a completely coherent, completely rigorous, completely mistaken picture of everything. And beyond that, the fuel gauge we talked about earlier finally reaches zero. Star formation is already well past its peak. The universe made most of its stars billions of years ago, and the rate has been declining ever since. The gas gets used up. The large stars die young. The small ones persist for a very long time, and somewhere on the order of 10 to the 14 years from now, the last star burns out. After that, there is no source of visible light in the universe. There are the cooling remnants, and then those cool too, and the darkness that preceded the stars closes back over the interval in which they existed. So let me go back to something I said early tonight and change what it means. I told you the darkness is not empty. It is unfinished. That every black patch overhead is a direction from which light is still on its way, and the sky is a delivery in progress rather than a picture. That is true, and it was hopeful when I said it, and I want to take the hope out of it now. Unfinished does not mean it will finish. An enormous fraction of that light is never going to arrive. Its sources are receding faster than it can travel, and the gap between us grows faster than the light can close it, and so those photons are not late. They are cancelled. They will travel forever and arrive nowhere. The darkness is unfinished in the way that a sentence interrupted mid-word is unfinished. There is no second half coming, and I told you the sky's a clock, because the amount of darkness in it is a direct readout of the age of the universe. It is still a clock. But now you know which way it runs. It is not counting up the light as it accumulates. It is counting down the interval in which the universe can still be read, and we are somewhere near the beginning of that interval, which is the only genuinely lucky thing in this entire story. Here is where I want to leave you, and I want to be honest that the feeling I am aiming for is not fear. It is closer to the feeling of holding something old and fragile. The terrifying truth about the darkness of deep space is not that it is empty, because it is not empty. It is full of light, light in transit, light stretched beyond your vision, light released before there were stars and still passing through your body, 411 photons to the cubic centimetre. It is not that the darkness is hostile, or that it is hiding anything, or that something is out there in it. Nothing is hiding. The universe has not concealed a single thing from us. The terrifying truth is that the darkness is a record, and the record is being erased. Every year, a little more of the universe crosses beyond the reach of anything we could ever build. The light that has not arrived yet is not cued. A great deal of it has already been ruled out, and the sky we can currently read, the one that told us the universe has an age and a beginning, and a shape and a fuel supply, the one that took our species 350 years to learn how to read at all, is the last legible page of a document that is closing. We worked out how to read it with about 100 billion years to spare, which sounds generous until you remember how close we came to not managing it. Kepler saw the problem in 1610 and could not solve it. Halley could not. De Chazeux could not. Olbers could not, and got his name on it anyway. Poe guessed it in a prose poem and died in a hospital in Baltimore the following year with nobody listening. Kelvin calculated it correctly in 1901 and was filed and forgotten. It took until the 1960s for anyone to assemble the whole answer, and the person who did it is a name almost nobody outside the field knows. 350 years to read a message that was printed above every human being who has ever lived, every clear night, for free. So the next time you're somewhere dark and you look up, try to do something slightly unnatural. Do not look at the stars. Look at the space between them, the part that seems like nothing, the part your eye slides over. That is the part carrying the information. Its blackness is telling you how old the universe is. Its persistence is telling you how much fuel is left. Its existence at all is telling you how narrow the band is that you're looking through. And its slow, silent, absolutely reliable growth is telling you that you're looking at this while it can still be looked at. The sky is dark for a reason. It is dark because we are early.